Today we're doing activity 21.4 and 21.5. They're very similar. 21.5 will only take a couple minutes. You'll see when we get there what it's going to look like. 21.4 is transformations. We've done transformations before. For example, you don't need to write this down. We know that parent function, we know how to plot it exactly. And we know that if it says this, that we're going to do a lot of things. We're going to shift it left and right. In this case, left 7. Vertical stretch or shrink and reflect it over the x-axis. Up, down. Remember all that? We did that for a bunch of different parent functions. So this lesson is a new parent function. And this lesson is a new parent function. But you're doing transformations, which is an old topic. Lesson. So we need to address some algebra that's going to come up in the lesson. So you can put this on your homework, scratch paper, your book, somewhere. We need to talk about, let's say, write this function down. Y equals 3 to the x. Anywhere. Without a calculator, we're going to make an XY table. See if you can fill in those 3 numbers on your own. Three to the 0. What's anything to the 0 power? 1. 3 to the first is 3, and 3 to the second is 9. Now let's add some numbers to our table. -1 and -2. Let's look at 3 to the -2nd power. I believe you've learned this in algebra, but maybe not. Did we know that an exponential, a negative exponent could be moved to the denominator and become positive? Did we know that? Okay, good. There's nothing left for the top except for your 1. So you can still do this without a calculator. The top is 1 and the bottom is 3 squared, or 9. So 1/9. If I do 3 to the negative first, if I have a negative exponent, I can move it to the denominator. It would become positive. Top, if there's nothing there, it's just a 1. So that's 1/3. You'll have to make some tables today like this.
Is there a time that the numerator would not be 1?
Not for a parent function like that, no. Just to kind of prove it to you or to show you a different example on your calculator, type this into your calculator. 3 to the -5th. Oh yeah, that's fine. Three to the -5th. Now do what I told you about negative exponents. I can put it in the denominator and it's positive. Type that in. 1/3 to the 5th. Works every time. So anytime you have a negative exponent, you can flip it. Technically, if it's in the bottom, which we're not going to have, but in algebra, you may have done some things like this. You could move any of them. So A has a positive 1, it stays. B is positive, it stays. C is negative, it's got to get moved. D stays where it's at. F is negative, so it has to get moved. Do you remember doing stuff like that? Kind of the topic we're using here for that. Wherever you did this first one that I did in green, go ahead and please do this function. create a quick XY table without a calculator. Maybe you want to start with the easy numbers again, like 0. Anything to the 0 is 1. 5 to the first is 5. 5 to the second is 25. 5 to the negative second is the same as 1 over 5 to the second. 5 squared is 25. And then this is going to be 5. You don't have to show work, but this is how you get it. These are some of our parent functions. There's actually an infinite number of exponential parent functions. Y equals 6 to the x, y equals 7 to the x, y equals 8. There's a bunch of them. It's not like linear, where there's one parent function, x quadratic, where there's 2, cubic. These all have exactly one parent function and it's listed right there. Or maybe we learned this one, I think. We do that parent function. Those have one parent function. Exponentials have different ones depending on what the base is. So any number is a new parent function. What we're going to do today is we're going to take a parent function like this and plot it. Then I'm going to have you plot something like this. It's going to be no different than what you've learned before. You will plot your parent function using these points. You will move it left and right, left or right, stretch or shrink, up and down. That's the lesson for today. Let's get started with question. Page 331B. Page 331, example B. You will see the parent function is listed first. Do we already have the points for that? Great. Plot those exact points so I can see the dots on your paper. I obviously can't tell how accurate your 1/3 and 1/9 are. They're going to be between 0 and 1. They're going to be small. There's no way for me to tell exactly where it's at. I like to fill it in with a dotted line, or if you have different colors, that would work too. Let me write this bigger. This is what we're going to do next. We're going to plot this function, but we're not going to use an XY table. We're going to use our parent function and our transformations. So this means I have a vertical what? Shrink by a factor of 1/2. So every height, half. Every single height is getting shrunk by 1/2. What does this do? Reflect over the x-axis. So again, I like to start with the easy point. I like to start with the y-intercept here at 1. I need to take 1/2 of that height. Well, it's at 1, so 1/2 of that is 1/2. Flip it over, negative 1/2. You can do it on your own. I'll kind of talk through the next one. I'm going to do this point that's up at 3. 1/2 of 3 is 1.5. Flip that over, negative 1.5. I went ahead and plotted another one that didn't fit on my graph because I knew when I took 1/2 of it, it would. I don't know if I will require that of you, but think about that. When you're plotting something, is it going to get bigger and get farther off your graph, or eventually will it fit? If it will fit, you should probably plot it. It has a height of 9. 1/2 of 9 is 4.5. Flip that over, negative 4.5. Don't let the fractions scare you. Let's talk about this fraction. This point I'm doing next currently has a height of a third. I need to take a half of a third, which is how much? A sixth. Even if you didn't know what number that was, don't you know it's just smaller than a third? And I can't grade your accuracy there. So it's going to be smaller than what it is now, and flip it over. Don't stress out about the exact number. The next one had a height of a ninth. Half of that's even smaller. I don't care if you know what number it is. Half of it's even smaller. Reflect it over. Flip the page. Go ahead and let's do, shoot. 3B. 3B. I would, below the graph or above the graph, perhaps write your parent function. How do we know what the parent function is? It's just one number with the exponent of x. So if you look, the thing right below the x, the base, is 1/3. That's how I know what my parent function is. Let's work on making the table for that. Remember, without a calculator, anything to the 0 power is 1. The first is the third. The second is squared. Let's talk about 1/3 to the negative second. Both the numerator and denominator have that power, so it's actually 1 to the negative second, 3 to the negative second. They both have negative exponents, so this needs to move to the bottom and this needs to move to the top. Three squared is 9. 1 squared is 1. Did some of you already figure out it was 9 before we did all that? Because it's the reciprocal of this one. Is that how you got that? Then it happened every time. So then to the negative first is the reciprocal of this one. So 3. Plot those parent function points.
Oh my God. You walk so fast.
Remember, order matters. Left and right goes first. How much are we moving ours to the left or right? Not 2. None. If it said that, we'd be moving it 7. There's nothing up there with the x. That would be the left and right. So we are doing vertical stretch by a factor of 2. Multiply every current height by 2. Then slide it down 4. Go ahead, do that on your own. Every height multiplied by 2. Slide that down 4. questions on parent functions or transformations? Here's some other questions that may be follow-up questions regarding this. It may ask you for the domain and range. Let's do that. We're not doing domain and range of the parent function. We're doing domain and range of the transformed function. Domain is x's. We're going in both x directions. That should always be the case. Unless it's some type of word problem and there's some scenario happening, you're going in both x directions. Your y value, is this going to go down to negative infinity? No. The parent function went down and approached 0. This function is going down and approaching negative 4. Which you can kind of tell from here. The lowest it's going to get, or get close to, is negative 4. The highest the graph goes is infinity. One of these numbers should always be infinity or negative infinity. The other should always be a specific number. I would not ask you for things like x-intercept in this case. For the parent function, I can ask you x-intercept because there is none. This one, without a calculator and what we're doing, I would not make me calculate the x-intercept. Would you be able to tell me if the blue function is increasing or decreasing? Exponential growth or decay? Asymptote, that's a new one from yesterday. The asymptote is simply the number it's approaching. It is approaching a height of negative 4. Asymptote. What is the end going towards what number? All right, that was 2B or which one? 3B. All right, let's flip to number 4. You don't have to describe it. Your homework will have some describing, which is like translate left to right, vertical stretch straight. Those are the describing things. You don't have to do that for this one. Just go to number 4. Identify your parent function and then graph this. Okay, what do you think the parent function would have to be? Yep, 2 to the x. Yep. Whatever is the base of that exponent. Go ahead, plot parent function and the transformed function. Talk about your fractions since you won't be able to use the calculator. This point right here has a height of a half. So I move it over. I multiply a half times 3. That's not too hard. Top times top, bottom times bottom. Its height is now 1.5. Flip it over, negative 1.5, then go up 5. Connect them when you're done. Makes it kind of a smooth curve. And it's going to bottom out. You can usually tell what it's going to. Oh, I better fix that last point. Let me recheck my last one. All right, so I need to work on this one. This had a height of 4. 6. 4 times 3 is 3/4. So negative 3/4 up 5. 1, 2, 3, 4, 5. That's better. You guys notice how I found my mistake? I knew that my asymptote is currently at 0, but when my graph gets shifted up 5, it should be at about 5. And I had a point that was up there that told me, hey, something's wrong. So I just rechecked my last point. I connect these. I can see my asymptote is going to 5 = 5. You should be able to do domain and range for this graph. I would not ask you for x or y intercepts. You would not have to calculate those. You could tell me that it's decreasing. You could tell me it's exponential growth, those kinds of things. All right, we are done with 21.4. 21.5 deals with E. Have we seen E in any math or science class before? Not capital E's, little e. But, oh, that's just what your calculator uses.
Oh, goodness.
E is a number, just like pi. Some people think pi is a variable or some abstract thing. It's a number. What number approximately is pi? Goes on forever, right? Irrational. E is kind of the same way. It's a constant used in science. If you look in your book at page 336, under the math tip, it says this. Exponential functions that describe examples of continuous exponential growth or decay use E for the base. You will learn more about the importance of E in pre-calculus and maybe other science classes. So today we're not studying what is E, when do we use it. We're just going to introduce how to graph it. Then when you get to it in pre-calc, you'll learn the ins and outs about it. I'm relating it to pi because it's a number. It's going to go on forever. To figure out that number, I can show you where it's at in your calculator. Go kind of catty corner up from 4. In blue, you'll see it says e to the x. Well, if we hit that button, so second e to the x, and we do e to the first, that will tell me what e is. 2.718. If you just remember 2.7, that's good enough for me. So on page 336, they have a table for you for your parent function, e to the x. Let's fill that in. E to the 0, anything to the 0 power is 1. E to the first, you will need to memorize that because you won't have a calculator. 2.7 is E. The more you do E squared, the more you'll have that memorized, but you should be able to do 2.7 times 2.7 without a calculator. This is not going to come up a lot, but you should be able to do 2.7 squared. I'm not going to make you do cubed. So go ahead, practice if you're not good at this. 7 times 7 is 49. 7 times 2 is 14. 18. Put a 0. 2 times 7 is 14. 4, 5. You guys remember how to do multiplication like this on a calculator? You guys are smart. Sometimes we forget basic arithmetic. So 7.3 is good enough. Again, once you do this once or twice, you'll have them memorized. You won't have to spend a lot of time doing your table. We did leave off -1 and -2, so let's add those. Based on the last lesson, you know that this is going to be the reciprocal of that one. So this is going to be 1 over 2.7, which is a fraction less than 1. And this top one is going to be 1 over 7.3, another smaller fraction less than 1. So this is a new parent function. That one we'll use a lot. It may be at most 1 question on a quiz, and the other ones would be like 3 or 4 questions. Let's do, I don't know which one you guys want to do. A, B, 4AB, or 5AB? 4B. Okay, so please plot this parent function on 4B. The parent function is listed, plot it. Did you purposely pick one without a stretch or shrink, Lydia? Yes, you did. Picking an easy one is smart because you have less work, but if we don't understand stretch or shrink, then it's not a good choice. Hey, if you know what to do and you want a quicker problem, then good. That was the right thing to do. Remember, no calculator, so we have e to the first is 2.7. E to the second won't fit on our graph, so you don't have to graph it. It's not going to get smaller. Take the current points. Left 4, up 1. Thomas, what would be the x-intercept of that graph? Of the...
That would be, I don't know.
When is the graph going to
Y
touch?
equals 0, right?
When?
It will never.
There you go. It will never. So if they ask you the x-intercept of this graph, none. It's not going to touch it. What you were telling me you were getting at an asymptote. Is this graph approaching 0, Thomas?
Yes.
Close. This red graph is approaching 0. This graph is approaching 1. Y equals 1 would be your asymptote. Oh, shoot. Yep, I just realized that when you said it. Ooh, let's see if I can just slide it on over. Thank you. Yes, I did go the wrong way. So let me go 1, 2, 3, 4, 1. Thank you. These answers still remain the same. Still no x-intercept. Still the same. Asymptote. Domain. Jordan, what do you think for domain? Yep, pretty much always going to be going both directions. Jillian, what do you think about a range?
1 to negative, or 1 to infinity.
Yep, the lowest this graph is going is getting close to 1, going up to infinity. Keegan, is this increasing or decreasing?
Increasing.
Definitely increasing. Wyatt, growth or decay? Growth. So remember this. Whatever your factor is or your base, if it's bigger than 1, it's growing, which you can see from the graph. But what is the number E? So it's kind of like 2.7, so that's definitely greater than 1 or growing. Am I missing any of those other questions I always ask? I wouldn't ask for a y-intercept because we're not exactly sure where it's going to hit.
Wait, so why don't we just put 2.7 for E? Like, why is it E?
Because it actually goes on forever, so 2.7 is not accurate. Like pi 3.1 would be like same idea, but it's actually not accurate. All right, I'm going to put up your homework. What I told last hour, which goes for you guys also, if you've been working on this homework for a half hour and you're not done, you may stop. I don't want this to take a super long time. I think a half hour would be about right. You'll need, I think, 4 graphs for the top, 4 graphs for the bottom. One of them is in your book, and they want you to put a bunch of them on one graph paper. You can use your book margin graph paper, or there's free graph paper in the back of the room, top of the file cabinet.